welcome back. Now we're going to look at the second rule regarding exponents, right? The second rule regarding exponents is what we're going to call the quotient rule. In the first one we dealt with the product rule. Now we are talking about the quotient rule. Right, so what's the quotient rule all about? Well, it's simply talking about dividing things that have the same base. Okay, when we divide variables, the same base variables with different exponents, what does this rule tell us? Okay, so let me tell you what the rule says. The rule says, well, if I have something that looks like x to the power of 2 divided by x to the power of 1, then there's something I need to do. I keep the exponents, and I simply subtract, I keep the base and I simply subtract the exponents. That's equal to x to the power of 2 minus 1, which is just equal to x to the power of 1. Right, which is just x. Okay, so that's what the quotient rule is all about. In general terms, when we express it, we're saying something like x to the power of m divided by x to the power of n is going to be x to the power of m minus n. And if you want to make it even more general, we can say x to the power of cow divided by x to the power of chicken. Then the answer is x to the power of cow minus chicken. Cow minus chicken. Right, so let's look at a few examples. Simply, if the bases are the same, you can do this. Now remember, all you need to do is determine whether the base is the same. Remember, this thing over here is the base, while this thing over here is the exponent. Now, let's do that. Let us look at that carefully. Let's use 2 to the power of 4, right, divided by 2 to the power of 3. And that's just going to be 2 to the power of 4, which is 2 times 2 times 2 times 2, right? In expanded notation, divided by 2 to the power of 3, which is 2 times 2 times 2. Now, if you look carefully, you can only cancel out things like this if the top is factorized and the bottom is factorized, right? In other words, you only have something multiplied by each other on top and something multiplied by each other at the bottom. And as you can see, the only thing that then remains over here is my solution of 2. So using the exponent laws is a quick way of doing this. We say it's 2 to the power of 4 divided by 2 to the power of 3. And just another way of expressing that, I can write it like this: 2 to the power of 4 divided by 2 to the power of 3. And that's going to give me 2 to the power of 4 minus 3, which gives me the answer of 2 over there. Now, as you can see over here, I use the full expanded notation, while at the bottom over here, I only used the exponent law. I saw that the bases were the same base. There's my base, and over there's my base. Right, the base was the same, and if the base is the same and I'm dividing things, then all I can do is I can just simply subtract the exponents. Okay, let's look at another example. Let's take p to the power of 16 divided by p to the power of 12. The answer is just going to be p to the power of, again, same basis, right? 16 minus 12. And then the answer is p to the power of 4. Now here's a few examples for you to consider. 3 to the power of 6 divided by 3 to the power of 5. Give me the solution over there. Okay, then I'm going to put another one over here quickly. Let's make it 7 to the power of 8 divided by 7 to the power of 2, and you can tell me what that solution is going to be. And then let's say, what about 5 to the power of 10 divided by 5 to the power of 4. Okay, so I'm going to pause the video and you can give it a go. Just remember, if the bases are the same and I'm dividing, then all I need to do is I need to subtract the exponents. So pause the video, do them 3, and then press play again. Okay, so the first solution here is going to be 3 to the power of 6 minus 5, which is going to be 3 to the power of 1. Over here we're going to have 7 to the power of 8 minus 2, which gives me 7 to the power of 6. And the final one over there, the bases are again the same, so I can just subtract the exponents, right? And the only time I do this is if I've got the same base variable. Okay, so that's going to be 5 to the power of 10 minus 4, which is equal to 5 to the power of 6. Okay, a few more examples for you to try in your book. Okay, so the first question here for you to try in your book is going to be 7 to the power of 13 divided by 7 to the power of 8. Let's make it 7 to the power of 8. Okay, I'm going to put that over there. You try that. Okay, and let's look at the next one. The next one, let's say 5 to the power of 8, right, divided by 5 to the power of 3. And you can give me a solution down there as well. Okay, let's choose a few more. Okay, 9 to the power of 5 divided by 9 to the power of 2. And then finally, 3 to the power of 12 divided by 3 to the power of 6. And you give me those solutions. And then I'm going to put one or two trickier ones for you to try, where I want you to combine the knowledge of the previous section that we just did. For example, 2 to the power of 2 multiplied by 2 to the power of 6 divided by 2. So what you need to do is you need to figure out how to do that one there as well. And then I'm going to give you one more here at the bottom. And let's make that 3 to the power of 6 multiplied by, with a dot, 3 to the power of 3 divided by 3 to the power of 2. Okay, so let's see what you can do. Pause the video, give that a go, and then press play and check our answers again. Okay, so let's look at the solutions of each of these individually. Now I'm going to start with the top one over here. 7 to the power of 13 minus 8. Well, 13 minus 8 is just going to be 5, so that solution there is 7 to the power of 5. This one over here is 5 to the power of 8 divided by 5 to the power of 3. Same bases again, so I can just subtract. It's going to be 8 minus 3, which is 5 to the power of 5, which is just 5 times 5 times 5 times 5, and so forth. Okay, 9 to the power of 5 divided by 9 squared. That's 9 to the 5 minus 2, which is just going to be 9 to the power of 3. This one over here, 3 to the power of 12 minus 6, is just going to be 3 to the power of 6. And finally, this one over here is going to be 2 to the power... Whoa, what do we do over here? Well, let's simplify that. Let's deal with the top first. Well, that's going to be 2 to the power of 2 plus 6. Remember, you don't multiply the exponents. You're multiplying things with the same base. All you need to do is you just add the exponents. It's going to be 2 plus 6. And then at the bottom, it's just 2 to the power of 1. Well, that simplifies to the following. 2 to the power of 8 divided by, that 8 should be smaller, divided by 2 to the 1, which is 2 to the 8 minus 1, which is just 2 to the power of 7. And finally, if you do something similar over here, you can see it's going to be 3 to the power of 9 above, divided by 3 to the power of 2, which is going to give me 3 to the power of 7 when I say 9 minus 2. Okay, give it a go, and all the best.